This provides a bridge between determinism. So here is the world of StatMech. And here is the world of determinism. The great puzzle of physics of at least 19th century was how was it possible to go from laws of mechanics, which are time reversible, to the real world over the troubled waters of statistical mechanics, where there is no time reversibility. What is the bridge? And this is it. If you understand how the partitioning of state space works, the idea is that in a state space, you maybe could have an ideal point that you can specify mathematically to infinite precision, but for all practical purposes, any state space has finite resolution. Other words to say it, the state space has to be coarse-grained by its intrinsic uncertainties. Could be experimental, could be laws, could be numerical errors, could be something. So there's always some finite level of this kind of slicing up the deterministic state space, where we come to the point where we cannot go any further. We have obtained the maximal partition we can obtain. Beyond that, things get too fuzzy. And that naive little observation renders everything totally different. Until now, every orbit was sacred. It had a deterministic law that we could ideally follow forever and computationally follow for a while. We had Lapland of time. But I also told you that if you used variational principle, we could actually have arbitrarily long deterministic trajectories doing things that we desired. The moment you realize that there is a finite precision in specification of initial states, you have gone from determinism to statistical mechanics. Now, again, it's a little bit like quantum mechanics. Quantum mechanics is not random, probabilistic, etc. I mean, every prediction of quantum mechanics is crisp and clean, and the only thing is that you have to scratch your head about how to interpret it. This will be easier on conceptual level. The moment we have partition and we've gone to this level of finite partition, we'll find ourselves in a world which is very close to foundations of statistical mechanics. But every calculation will be equally crisp as it is in quantum mechanics, not any worse.